Hello, class. This is Mr. Eggleston. This is the second take of the Unit 4.1 through, or excuse me, 5.1 through 5.4 quiz review. All right. Unit 5 is all about something called functions. So I just want to point it out. This is all about functions. And this is the basic background of a function. So here's the key. I already did part of this, so some of this is already written. Some of it's not written, so we'll find out as we go. All right, so here we go. First kind of question is going to be the total statement. The total number of eggs needed at a breakfast cafe on a given day, E. So E is the number, it's a given day, is a function, or no, excuse me, is the total number of eggs. So E equals number of eggs. Okay, is a function of the number of customers that day, N. So N equals number of customers. Okay, so E is a function of N. That's how it would be written. All right, so for each input, there may be more than one output. No, because it's a function. That's by definition incorrect. Right? For a function, each input goes to one output. The total number of eggs needed is the input. No, that's actually the output. The number of customers is the input. All right, and that's true. Or the number of customers is the output. No, that's false. So it's C. I hope that's pretty straightforward. The function S gives the number of hours of sleep that Marquis got on the nth day of the month. Interpret each statement in the context of this problem. So the first one is S of 6, S evaluated at 6 equals X. What that means is on the 6th day, Marquis got X hours of sleep. Notice it's X, so we don't know. It's an unknown, all right? The second one is that S evaluated at 1 is greater than S evaluated at 2. Well, that means that Marquis' hours of sleep on the first, oh wow, that's bad. Marquis' hours of sleep on the first day of the month is greater than, because of the greater than symbol. Okay. Right here. Then the number of hours of sleep he got on the second day. All right. I hope that makes sense. It's pretty straightforward. Should take you just, a couple minutes to do the problem 1 and 2. Question 3. The amount of premium gas pumped by the next 10 customers at a gas station is recorded as well as their total cost. Consider the mapping that assigns to each amount of premium gas pumped the corresponding price. Can this mapping be considered a function? Why or why not? Well, the mapping is that kind of formal way of representing functions where you have like an input and you have like 1, 2, 3, and outputs from the function like 20, 30, and 40. And each input is only, this is a mapping where we point arrows, that each input goes to only one output. So they're asking you, can the input, the amount of gas pumped, is that a function, or is the cost a function of that? In other words, each individual amount pumped will have a unique charge, right? It'll be worth, if you pump 10 gallons at this gas station, the first customer, and paid $50, and a second customer pumped 10, he would also be paying $50 unless something funky's going on. All right, so yes, because each number of gallons pumped has a unique price that you have to pay. All right, okay, question 4, the input of a function f is any real number. Okay, so we know the input of f is any real number. That's all real numbers. That means any number. The output of the function f of x is always 2 less than 3 times the input. All right, so first question is graph f of x. So let's see if we can write this out. The output of the function f of x is always equal to 2 less. Ooh, wow, that's interesting. Okay, 2 less than 3 times the input. So here's 3 times the input. We'll call that x minus 2. This is the statement 2 less than 3 times the input. You have to interpret this. So once you see this, you know that, hey, this is a line, has a y-intercept of -2, and a slope of 3 over 1. So we go up 1, 2, 3 to the right, 1, 1, 2, 3 to the right, 1, 1, 2, 3 to the right, 1. I like putting down as many points as possible. Down 1, 2, 3 to the left 1, which also gives you a positive 3 slope. And we have this. And we just connect it with a straight line. I make mine go a little bit longer so I can just scooch it up so it fits the entire space there. And there's your graph. Write an equation for f of x. Well, the equation is I already wrote. So f of x is 3x minus 2. All right? 3 times, this is 2, this statement, and you have to be able to interpret it, is 2 less than 3 times the input. All right, fifth question. Let S of t model the number of subscribers in thousands. Just kind of remember that. Keep that in the back of your head. All right, in thousands. So 1 is 1,000, 2 is 2,000, and so forth. To a certain podcast over time in months t. So t is in months. So this 5 right here is 5 months. Okay. What time period had the greatest increase in the number of subscribers? Okay, what time period? So we look at this, we see the increase in this region right here is you go up 2 to the right 1, so that's 2 over 1, so that's a slope of 2. This increase in this region right here is you go up 1,000. I guess it's in thousands. So this is 2,000. You can write that, or you can just leave it as 2 and remember. So this is 1,000, goes up 1,000 in 1, 2, 3, 4, in 4 months. This is 2,000 in 1 month. All right, greatest increase. So we don't have to worry about this piece here because that's a decrease. So we don't worry about that. It went down in that time period. But this one right here seems to go up 1, 2, 3. Whoa. Okay, let's just go from here. It will go up 1, 2, and then 2 whole ones, and 1, 2, 3, 4. So that it's actually a total of 3. So this goes up 3,000 in 1 month. And the last piece is a decrease. So the time period would be between, let's see, this is 5, 6, 7, 6, 7, sorry. So that'll be from 7, 8, 9, 10. Wait. I'm blowing this. So it'll be 6 to 7. What time period? In month 6, because the slope is largest. The slope of the graph is largest. Okay. Find S evaluated at 5 and interpret your answer in the context of this problem. All right. I'm going to erase what I wrote here because that was just for that question. And we don't need it to clutter up the graph. Find S of 5. Well, here's 5 on the input. We go up. It's right here. It looks like it's 3,000. So you can say it says find S of 5. So S of 5 equals 3. That means in the 5th month, the podcast had 3,000 subscribers, I guess. Subscribers, 3,000 subscribers. Are there any time periods when there was no change? Well, yeah, between here and there, because the number of subscribers is flat, yes. Between months 5, 6, 7. Okay, between month 8 and 11. Okay, between months 8 and through, I should say through 11. 11. Okay, and you could say because, even though they don't ask, because graph is flat. At what time or times were there 2,500 subscribers? So 2,500 is between 2 and 3, midway. It's right here. Because remember, this is in thousands. Oh, wow, okay. What? There it goes. All right, so it looks like it's at months 1, 2, 3, at month 4, and that's it. So it's at months 3 and 4. Oh, okay. During months 3 and 4. Okay, did the podcast ever lose subscribers? Well, yeah, that means, does the graph ever go down, have a negative slope, is what they're basically asking you. Okay. So looking at this, it looks like it goes down between month 5, or excuse me, 1, 2, 3, 4, 5. Okay. It looks like it's going down. I don't know what that was for. I just blanked on. Between here and there, and between this month and that month. So, yes. Two periods. Between months 5, 6, and 7. Between months months 5 through 7, and this junk on my screen here, months 11 and 12. And 11 and 12, because the slope is negative, right? Here's 11, here's 12, so it's during that month. Okay, there you go. Question 6. Now, if you're wondering how many questions, there's 7. So question 6, let f of x equals negative 2x plus 1. Also note that selected values of the function g are given in the table. So here's a table method or listing of values, and they call that g, so I'm just going to make it big. G of x is the table, and I'm going to write over here f of x is this equation. So evaluate f at 1. So they really just want you to plug in 1 in for f. F evaluated at 1 is going to be negative 2 times 1, because we replace x with 1, plus 1. That's going to be negative 1. Evaluate f of 1, it's negative 1. Find the y-intercept of the function g. Well, the function g is the table, and the y-intercept occurs when x equals 0. So kind of write this x equals 0. We want to know the value of g when x equals 0, and it's right there. So the y-intercept is 5. G of 0 equals 5. Which is greater, f of 2 or g of 2? Well, let's calculate each. F of 2 is going to be negative 4 plus 1. Negative 2 times 2 is negative 4. Plus 1 is going to be negative 3. And g of 2 is negative 1 from the table. Which is greater, f of 2 or g of 2? You got to be careful. A more negative number is smaller, because remember, negative 3 is to the left on a number line. If you think of a number line, here's 0, negative 1, negative 2, negative 3. So here's negative 1 right there. Here's negative 3 right there. Negative 3 is to the left. So, and negative 3 was f, so which is greater? G of 2 is greater than f of 2. You gotta be careful of the negative numbers. Then it says find f of 4 plus g of 2. So f of 4 is, you plug 4 in for x, so it's negative 2 times 4 plus 1. That's going to be negative 8 plus 1. Negative 8 plus 1 is negative 7. And then g of 2, we already figured out was negative 1. So f of 4 plus g of 2 is negative 7 plus negative 1. It's negative 8. Okay. And there you go. That was question 6. Okay. On question 7, the last question, notice we went from 6 to 7. 6, 7, the complete graph of y equals p of x is shown. So here's the complete graph, right? This is all of it. Identify the domain of p. Well, domain is the input, which is the x. It's the independent variable. So we see that the graph begins at x equals negative 3 and goes all the way through to x equals 3. So the domain of p would just be negative 3, x, 3. Identify the range of p. Well, the range of p is the output. It's the y value. You see the y values begin at y equals 0 and goes all the way up past 4, even though 4 right here is the y-intercept. They actually goes all the way up to 5. So the range is going to be 0. Actually, let's use function notation for this. It's going to be p of x is between 0 and 5. What are the x-intercepts? Well, the x-intercepts are where the graph touches the x-axis. It's at negative 2 and positive 2. So the x-intercepts would be as an ordered pair. I'm going to write them as ordered pairs. Negative 2, comma 0, and 2, comma 0. And there you go. That's the quiz. Not really that hard. This is all very reminiscent of your homework sheets that you got from the curriculum. So good luck on the quiz.